So today we're starting with our week 8 lecture that is called number patterns. So as you know, patterns are everywhere, okay, and they can appear as geometric patterns or numeric patterns, okay. So before we move on to into the content, we need to know what is meant by figure eight numbers, okay. Figure eight numbers are numbers that can be arranged as a regular polygon made of dots, okay. If you can arrange the number in the shape of a regular polygon, then it is called a figure eight number. Figure eight numbers are also called polygonal numbers, okay, because they form polygons. So figure eight numbers or polygonal numbers, they are the same. They are numbers that can be arranged to form a shape. So today we are going to look at 3 types of figure eight numbers. They are triangular numbers, square numbers, and pentagonal numbers. Okay, so we're going to look at the characteristics of triangular, square, and pentagonal numbers, and we are going to derive the formula for number patterns. Okay, so we are going to start with triangular numbers. Okay, you see the numbers here, the dots here, the 1 dot. Okay, this is 1. Here we have 3 dots. How many more from the first one?
2.
2. So the first number is 1. For the second number, we add a row with 2 dots. So this is the first row. Okay, first row. Row 1, sorry. And this is row 2. Okay, so this is row 1. And this is row. I don't know why the pen is going crooked. Okay, row 1 and row 2. Okay, so when we move on to the third number here, how many dots more do we have from the second number? 3 dots more, right? So first we have 1 dot and then we add 2 dots here, correct? We add 2 dots here. And then the third number we add 3 dots. Fourth number we add 4 dots here. Fifth number we add 5 dots, correct?
Yes.
Okay. So this part that we add here, the one that we're adding here, the parts that we add here, they are known as gnomons. Gnomons, okay? This is a gnomon. Every time you add a part to the existing number, we are adding a gnomon. It is called a gnomon, okay? Can you understand that? Okay, so our first triangular number is 1, and then we have 2, and then we have 3, 4, 5. Each time we add 1 new row. This is row 1, row 2, row 3. Row 1, row 2, row 3, row 4. Okay, row 1, row 2, row 3, row 4, row 5. Okay, that's how you see. So each time we add 1 new row or 1 new gnomon. Okay, here we are adding 2, 3, 4, 5. Okay, so your triangular numbers, you can also draw them like this. 1 dot. The second number, you add 1 new row, 2 dots. You're adding 2. Okay. Third number, you add 3 dots. So you're adding 3. Fourth number, you're adding 1 row of 4 dots. Fifth number, you're adding 1 row of 5 dots. Okay. Sixth number, you're adding 1 row of 6 dots. So the number of dots on this side is 2. The number of dots on this side is 2, 2. The number of dots on this side is 3. Here, 3. Number of dots here, 4. Here, 4. So what kind of a triangle is this? 4, 4. This side and this side is the same. This side and this side is the same. So what kind of a triangle is this?
Equilateral.
equilateral triangle. Equilateral triangle, correct? Segitiga sama kaki is what? What do you call segitiga sama kaki in English? Are all the sides the same?
Segitiga sama sisi.
It's not equilateral triangle. What do you I cannot remember the term. Okay, this segitiga sama kaki. You know that, This side and this side is equivalent. So here the number is 1. Here is 1 plus 2, correct? 1 plus 2, you add 2. So here we plus 3. So the former number is 1 plus 2. We add here plus 3. Here is 1 plus 2 plus 3, this number, previous number, plus 4. Here is 1 plus 2 plus 3 plus 4. And we add a new row is plus 5. This one is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So what is the next number? So what is the number here? 1, 3, this is 6.
6, 9.
Are you sure? 10. This is
10. This is 15.
15. 15, 21. So what is the next number? Okay, the next triangle has how many dots on each side here? How many dots on this side? Here, 1, 2, 3, 4, 5, 6. Here, 7, right? 7 dots here, 7 dots. So this is the first triangular number, second triangular number. This is T1, T2, third triangular number, fourth triangular number, fifth triangular number, sixth triangular number, seventh triangular number. So what is the seventh triangular number? Plus how much here? We are adding one new row of how many dots? 6 triangular number, we add one row of 6 dots. 5 triangular number, we add one row of 5 dots. 7 triangular number, we add one row of
28.
Yes, we are adding one row of how many dots?
28.
Okay, let's look at this number again.
28.
First number is 1, right? The triangular number is beginning with 1. Second triangular number, we add one row of 2 dots. Third triangular number, we add one row of 3 dots. Fourth triangular number, we add one row of 4 dots. Fifth triangular number, we add one row of 5 dots. Sixth triangular number, we add one row of 6 dots. So the seventh triangular number, we are going to add one row of how many dots?
7 dots.
7.
Yes, one row of 7 dots. So our number will be 1 plus 2 plus 3 plus 4. We are going to add the previous number, plus 5 plus 6 plus 7. And this will give us
28.
28. Very good. So now, how many dots? Okay, how many dots are there in the 60th triangle? Can anyone tell me that?
60 dots.
60? How many dots are there in the 60th triangle? This is first triangular, or you can say in the 60th, or we can say in the 60th triangle. I put like this, triangular number, okay? Triangular number. So our first triangular number is 1. Second triangular number 3. Third triangular number 6. Okay. Fourth triangular number 10. Okay. And if you look for patterns, okay? First one, T1, you have one dot only. Triangular number 2, you have 2 dots on the side. Each side has 2 dots. Triangular number 3, you have 3 dots on the side. 4 means 4 dots on each side. 5 means 5 dots on each side. Sixth triangular number has 6 dots. Seventh triangular number has 7 dots. How many dots does the nth triangular number have on each side? Okay, how many dots does the 60th triangular number have on each side?
60.
Yes, each side is 60. So how are we going to find out how many dots are there all together in the 60th triangular number? How are we going to find that out? We need a formula, right?
Yes.
Okay, so how do we derive this formula? Okay, if you just look at the triangular numbers, okay? Your triangular numbers are 1, okay? 1, 3, 6, 10, 15, 21, 28, and so on. From here, can we see any pattern? Can we see any pattern here? What is the difference here? What do we add here?
+1.
2. Plus 2, right? Here we plus 3, here we plus 4, here
4.
we plus 5, here we plus 6, here we plus 7. And if you look at the second difference, 3 and 2 is 1, 4 and 3 is 1, 5 and 4 is 1. So we know that there is a regular pattern here, okay? So how do we derive this pattern, okay? So because we cannot find the 60th number unless we come up with a formula, okay? So let's see how we can derive this formula, okay? Okay. Okay, if you look at this first triangular number, okay? The first triangular number is 1 dot, right? It's 1 dot, so it's 1. Second, sorry. This the green one. Let's look at the green or the yellow, either way. The green, let's look at the green one, okay? So the first triangular number here is 1. Here is 3. Then we have 6. After 6 is 10. After 10 is 15, right? Okay. So if we make this into rectangles, if we fill the space, okay, to make this rectangle, we add 1 dot, right? So this is our triangular number 1, 2, 3, right? 1, and we add 1 row of 2. It doesn't matter which way it's facing, either it's facing this way or that way, it doesn't matter, okay? So now to complete the rectangle, we add 1, 2, 3. Okay, we add 3 dots, and we have got a rectangle here. Here, our third triangular number is 3 dot, third triangular number. This is third triangular number, okay? And it's 1, 2, 3. Third triangular number, we have 3 dots on the side. We complete the triangle. It's like this. We don't have a proper rectangle, okay? We don't have exactly 2 halves. We want to complete the rectangle so that we have exactly 2 halves. The 2 halves are the same size, okay? So we add another 3 dots here and we complete it. So T4 is like this. So we complete it, and T5 is like this. So how does T6 look like? 1, 2, 3, 4, 5, 6. Correct? 1, 2, 3, 4, 5, 6. This is our T6, correct? Okay, so this is our T6. Now we need to complete this. If we want to complete this to make a rectangle, we have to add 1, 2, 3, 4, 5 here, right? And we add another 1, 2, 3, 4. 4 here. So we still have 6 here and 6 here. Correct? But we have to add, but you see we have This side we have 6 and 6, but this side we have only 5. So if we want to make this both same size, we had to add another one here. So we get 6 here. Okay. 7, 3, 5, 2, 3, 4, 3, 4, 5, 6, 7. Okay. Alright. So it's like this. So that we have 2 halves. So that we have 2 halves. That's exactly the same. Okay. So we complete the rectangle so that we have 2 halves that's exactly the same. Okay. So for n is 1. Okay. How many dots do we have here? So here we have, if this is 1, n is 1. If n is 1, so we have how many dots here? If this is n, this is the original one, right? If this is n, so now here we have n plus 1, correct? If this is the original one, n, and this is n, right? So this one will now be n plus 1, correct? If this is n, now this one will be n plus 1. Okay, if this is n, now this will be n plus 1. If this side is n, this will be n plus 1, correct, right? N here is 1, 2, 3, 4, 5. So here will be 1, 2, 3, 4, 5 plus 1. So it's n plus 1. Okay? So now let's look at that. Let's calculate the number of dots in the rectangle. Okay. In the first rectangle, how many dots do we have?
2.
2, right? So we can write that as we have, it's actually n, this is actually a rectangle, right? The length is 2 and the width here is 1. Okay. For when n is 1, so when n is 1, what do we have? We have 1 times 1 plus 1, correct? When n is 1, we have 1 times 1 plus 1 because this is a rectangle. This is a rectangle. When n is 2, term 2. When n is 2, so we have 2 times 2 plus 1, correct?
Yeah.
When n is 3, so we have 3
3
times
times 3 plus 1.
1. Here,
4
4 times 4 plus
plus
1. Here,
1.
5 times
5,
5
5
plus 1.
plus 1.
And these are the number of dots in the rectangle. But our original number is only the green one, right? So how do we calculate the number of dots in the triangle? We know the number of dots in the rectangle. Here, 1, 1. So what is the number of dots in the triangle? In this triangle, how many dots? How many? It's divided by 2, right? It's 1 into 1 plus 1 divided by 2. It's 2 into 2 plus 1 divided by 2. Because it's half of the rectangle, correct? It's 3 into
Yes.
3 plus 1 divided by 2. 4 into 4 plus 1 divided by 2, or 5 into 5 plus 1 divided by 2. So what is the nth term? Tn. What is the nth term? Fifth term is 5 into 5 plus 1 divided by 2. So what is the nth term? What will the formula be like?
N times n plus 1 divided by 2.
Yes. Therefore, the nth term for triangular numbers can be obtained using this formula. Okay? Tn. The nth term is n times n plus 1 over 2. Now, can you find the 60th triangular number? So it is how much?
$1,813.
1830.
Yes.
Alright? Yes.
Yes.
So now that we have derived the formula, we can find any triangular number. Okay? So if I asked you, what is the third triangular number? What does that mean?
Third,
Yes, if I say third triangular number, what does that mean?
3,
The T3.
Yes, T3. And what does it mean?
$15 dots.
15 dots. Huh?
Six
T3, that means how many dots on one side? Okay, it's called an isosceles triangle. Okay, when you have two sides that are equal, it's called isosceles triangle. Huh? So how many, if T3, how many dots are there on each of the equal side?
3.
3, right? Term 3 means third triangular number has 3 dots on each equal side. Huh? The sixth triangular number has how many dots on the side?
6.
6. Okay, very good. So we are finished with this. But there's also another pattern here if you notice. If these are the triangular numbers. After 15 is 21, 28 and so on, right? So if you look, there's another pattern here. 1 plus 3 is? 1 plus 3 is?
4.
4. 4 is a 2 square, right? 4 is a square number. What is 3 plus 6? 3 plus 6 is?
9.
9, which is a square number. 10 plus 6? 16.
16,
Also square number. 10 plus 15?
25,
25. Square number. 21 plus 15?
36,
36. Square number. 28 plus 21?
49.
49. Also square number. So what can we say about this? What can you deduce from here? What can you deduce?
Sum of number before is total of square.
Again, the sum of?
Number before,
Okay, correct. Or we can say the sum of two consecutive, that means berturut-turut. The sum of two consecutive triangular numbers always results in a square. Okay, so that is the other pattern that we can see here. Okay, so we have finished with triangular numbers. Okay, so now let's go on to square numbers. Okay, these are square numbers. They are square numbers are polygonal numbers. So square numbers here begin with 1, 4, 9, 16, 25. What comes after 25? 36. So we have 1 and then we have 4 here. So how many dots did we add here from 1 to 4?
3.
3. Yes, we have added this part here. Then from 4 to 9, we have added this new. How many have we added? 1, 2, 3, 4, 5. We have added 5. Here we have added 3. For the next number, we have added another 7. For the next number, we have added another 9. So the next number here, we will be adding another. We have added 3, 5, 7, 9,
11.
11. Yes, we'll be adding another 11. So what do you call this?
Odd number.
Okay, what do you call that part? This piece here, what do you call this piece? So, what do you call the piece? Gnomon, it's called gnomon, okay? This every part, every piece of or every part that we add to the previous number is called a gnomon. Okay, so here for square numbers, the gnomon here is odd numbers. Okay, we keep adding odd numbers to form the next number. Okay, so these are square numbers. Okay, why square numbers? The side here is n, here is n, and 3, 3, 4, 4, 5, 5. So they form a perfect square. Okay. 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 If you look at your numbers here, a square number can only end with digits 0, 1, 4, 5, 6, and 9. Okay. A square number can only end with these digits. Okay. The number of zeros at the end of a perfect square is always even. For example, 100 is a perfect square. 2,500 is a perfect square because the number of zeros are even. Okay. 80 is not a perfect square, only one zero. Number of square is not even. Okay. 250 is not a perfect square because the number of squares is not even. Okay. So these are some of the properties of square numbers. So how do you find the 19th square number? How do you find the 19th square number? You tell me, what is the 19th square number? Anyone? First
361.
Okay, correct. Okay, so how did you derive that? How did you get that answer?
19 squared.
19 square, huh? Okay, so if you see the first number here, this is the first number, it's 1 times 1, right? Second number, 2 times 2. This is T1, T2, huh? So T3 will be 3 times 3. T4 is 4 times 4. T5 is 5 times 5, huh? T6 is 6 times 6. Term 6 is 6 times 6. So term n, the nth term will be n times n, which is n square. Okay, so the formula for the nth square number is n square. So if you're finding the 19th square number, it is 19 square, which is 361. Okay. Okay, square number is very direct. Huh? Okay, so you don't have any problem with this, right? Okay, so we are going to move on to the last type of numbers, which is the pentagonal number. Okay. Okay, pentagonal numbers. As you can see, they form the shape of a pentagon. So this is a figure number because they form a shape. So that's why they are called pentagonal numbers. Okay, so the first number is 1. First number is 1, 5. If you see the first number is 1. Okay, so how many more did we add to become 5?
4.
Yes, plus 4. So we have added this part here, okay? And then, how many more did we add to become 12?
7.
7. So we have added this part here, correct? Here, we added this part here. The next number, we keep on adding this part. So this is called the,
Gnomon.
yes, correct. The others don't dare to pronounce it, okay? So this is how we find the next number, okay? And if you notice, pentagonal numbers, they all share the same vertex. This vertex, they all share the same vertex, okay? So this is the first number, okay? This is T1 is 1, T2, so it's 5, okay? The term 3 is 12. You see T2, there are 2 dots in each side, okay? T3, there are 3 dots on each side. So term 4, 4 dots on each side. Term 5 will have 5 dots on each side. What about the 6th? How many dots will there be on the 6th pentagon? Can you try drawing the 6th pentagon on your paper there? Because when you look at it, it's simple, but when you draw, it's much more difficult, okay? So can you just try briefly, very quickly draw it?
50.
How many?
50.
50. You said that T6 is 50. Anybody else got any other answer? Okay. Why do you say it's 50? Okay, from 12 to 22, how many did we add?
10.
Here to here?
13.
13. So the next number we are going to add?
15. I guess 16.
Yeah, 16. We're going to add 16, correct. We're going to add 16 to 35. So that will be?
51.
51, yes, correct. 51. Okay, very good. 51. Okay. So let's see. What is the 100th pentagonal number? Anybody? Do you see a pattern here?
Yes, but it cannot derive.
Cannot derive the formula. A bit difficult to derive the formula, okay? What's the pattern here? We know it's plus 4. This is plus 7, and then plus 10, plus 13. But if you look at this, the first difference, but if you look at the second difference, okay, this is plus 3, 3, 3. So you know there is a regular pattern here, okay? So let's go back and see how we can derive the formula here, okay? Okay. One minute, just give me 1 minute. Okay. Okay, we look at this pentagonal number. This is what number, pentagonal number? This one, this diagram here on my left. What number? Is it the first, second, third, fourth, fifth?
The left one,
Yes, the left one.
4.
This one. 4. Why do you say it's the fourth?
Because it has 4 gnomon.
It has 4.
4 gnomon. Side.
We have,
Out-
we have 4
outer
dots on each side. Okay, so let's look at this pentagonal number. Let's look at this figure, okay? So this figure, this pentagonal number, we can divide it into triangles like this, right? So we see 3 triangles here, correct?
Yes.
Okay, so what triangular number is this one here?
The left one,
Yes, the left one. This one here.
4.
What triangular number is this? Is this the fourth triangular number?
Yes,
Why do you say it's the fourth triangular number?
because it has four in each side, in the three side.
Okay, so we have the fourth triangular number. Okay, so this pentagonal number, it consists of the fourth triangular number. And what about the green one? What triangular number is this?
3.
Yes, and the third triangular number. And the next one? This one is the third triangular number. This is the fourth. How about this?
Same, 3.
Also 3. So we have the third triangular number, we have 2 of it, correct? So what is the formula for triangular number? So what is this? What is the value of the fourth triangular number? We know that the formula for triangle number is n into n plus
N
1
plus 1
divided
divided
by 2. So the
2.
fourth triangular number is 4 times 4 plus 1 over 2, correct?
Yes.
Plus, what is the third triangular number?
The 3.
3 times 3 plus 1 over 2.
2.
But we have 2 of this, right? So it's times
2.
2. So how much is this? 4 plus 1, 5. 5 times 4, 20. Divided by 2,
10.
10. Plus 3 plus 1, 4. 4 times 3, 12.
12.
So this is 22.
22.
Correct?
Yes.
So the fourth pentagonal number is 22. How about this? This is the what number pentagonal number? The 1, 2, 3, 4, 5 dots
5.
on the side. So the fifth pentagonal number is also consists of what triangular number is this? Consists of?
5.
Yes, consists of the fifth triangular number and
2 fourth triangular number.
yes, correct. And the fourth triangular number multiplied by 2. So we have the fifth triangular number is 5 times 5 plus 1 divided by 2 plus what is the
4.
fourth triangular number is 4 times
4
4
plus
plus 1 divided by 2 is
Times
whole things times by 2. Okay, so what do we have here? 6 times 5, 30 divided by 2, 15 plus 4 plus 1, 5 times 4, 20. This is 35. Okay, can you see a pattern here? Now can you see the pattern here?
Yes, yes.
Okay, if you can see the pattern here, what is the end pentagonal number? Equivalent to consists of the what triangular number? Fourth pentagonal number is fourth and third. Fourth pentagonal number. This is the fourth
Four.
pentagonal number. Fourth pentagonal number. Okay. So it consists of the fourth and the third triangular number. Fifth pentagonal number.
5 and 4.
So the nth pentagonal number. The nth triangular
number.
and
and
N
2
minus 1.
minus 1.
Yes, excellent. And the n minus 1 triangular number, okay? So what is our formula like? It is,
N plus
okay, I'm going to go use a new board, okay? 1 meter. Okay. So we know that the nth triangular number consists of the the nth pentagonal number consists of the nth triangular number and the n minus 1 triangular number. So therefore that is nth triangular number is n times n plus 1 over 2 plus
N
n
N
minus 1, correct? Times
N
n
minus
minus 1 plus 1
1 over
over 2
2.
over 2 then? Yes, times by 2. Okay, so what do we get here? N times n plus 1 over 2 plus, what is
N
this?
N
N
square.
times n minus 1, correct?
Oh yeah, yes.
Yeah, n squared also can. Okay, can we simplify this even more? What do we get here? This is n times n plus 1 plus 2n times n minus 1 over 2, correct? So this is n squared plus n
Plus
plus
1
2n squared minus
minus no
n squared plus n plus 2n squared minus 2n over 2.
2
So n squared plus 2n squared is 3n squared. N minus 2n is minus
1
n
over
over
2.
2. So this we can rewrite as n into 3n minus 1 over 2. So this is our formula. Actually, you can use this also, or a much simplified version is this one. Okay, a much simplified version is this one. Okay, so to find the nth pentagonal number, this is the formula that you're going to use. So now can you find your 100th pentagonal number? So this is going to be 100 into 3 times 100 minus 1 over 2. How much is this?
14905 in 950.
Are you sure? Again?
14950.
300 minus 1 is 299. Correct?
Yes.
29900 divided by 2. So we get this. Okay, good. Very good. So do you understand that?
Yes.
So we have derived the
Yes.
formula for triangular numbers, pentagonal numbers and square numbers. Okay, let's do one last summing up. Okay, so let's look at triangular numbers. So your triangular numbers start with, tell me the first few. 1,
1, 3,
yes, 3,
6
6,
10
10,
15,
15,
21,
21. Okay. How about the square numbers? Square numbers start with 1,
1
4,
4,
9,
9,
16,
16,
25,
25,
36.
36, and so on. Okay. Then we have our pentagonal numbers. Okay. So pentagonal numbers start with 1, 5, 12,
22.
22, 35, 51, and so on. Okay, you notice that all, what do you call these numbers? What type of numbers are these?
Figurate.
Yeah, figurate or polygonal numbers. These are figurate and polygonal numbers. Why? Because you can draw regular polygons with these numbers. These numbers can be represented as regular polygons. Okay, so all these figurate numbers, if you notice, they all start with 1. Okay, so the first and the second triangular number together will give you the square number. Okay, all this together will give you a square number. Okay, so we have looked at number patterns for these 3 types of numbers, and we have learned how to derive the formulas for these kind of numbers.